Hello and welcome to part 4 of the Introduction to Differentiation series that I'm doing. In this video, we're going to take a look at turning points and the second derivative test, and we're going to see how to find the turning points, what are turning points and what is their importance, and how to classify them. So let's get right into it. So first, let's say we have a curve on the xy plane. Okay, that looks something like this. Let's say this is some function f of x. Okay, so let's zoom in a little bit and see what is happening. So let's say we want to take this part over here. Let's take a look at this part of the curve over here. What is happening? We can see that at this part of the curve is going this way. Or basically the curve is having a slope that is this way, or basically the curve is having a positive slope. Okay. What about the curve in this portion over here? The curve is going this way, or it's moving downwards, or it's having a gradient or a slope looking this way. So we know that this gradient or this slope is a negative gradient. Okay. So let's say in this part where the gradient is positive, okay, we know that it's a curve, so at each point the gradient is different than the other point. So let's take a look at what's happening in those 3 points. So let's say the gradient here is let's say it's a positive number, let's say it's 2. The gradient over here is, let's say, 1. Okay, why? Because we know that the gradient is the slope of the tangent at that point. I know that tangent at this point is like this, and the tangent at this point is like this. So we can see that this line is steeper than this line, so the slope is higher, or the gradient is higher for this point than this point. So in other words, the curve is getting less steeper. Over here, the curve is, let's say, having a gradient of 0.5. And let's take a look at over here. We know that the gradient is negative over here. So let's say the gradient is negative 0.5. Here, the slope is getting steeper. Let's say it's negative 1. Here, m equals negative 2. So what we can see when we move along the positive x direction, or when x is moving to the right, we can see that as we're moving to the right, the gradient value decreases from 2 to 1, and then from 1 to 0.5, and then it decreases furthermore, it becomes a negative value. So this means that the gradient is decreasing, and then it means that there is a point where the gradient reached a value of 0. This point is the point that we call a turning point. This is the turning point where the gradient is 0. And we know that if we have any line with a gradient of 0, it's basically a horizontal line like this. And if we try to draw the tangent to this point over here, which is the turning point, we can find that it's a horizontal line, meaning also and showing further that the slope or the gradient at this point is 0. So basically, this right here is called a turning point. Over here, we have the same thing. The gradient is also changing from a negative value to a positive value, because over here it's looking like this. So we know that this point over here also will be our point where the slope is 0. This is also a turning point. So we can see that those 2 points are turning points, or are points where the slope is 0. So we know that a turning point can look something like this, or it can look something like this. When it looks like this, it's said to be a local minimum. Why is it a local minimum? Because it's the minimum value in the region that it is in or the region or the points beside it. In this region, this is the lowest point. It doesn't mean that it's the lowest point of the whole curve. No, there could be lower points than this, but locally it's the minimum point. And similarly, this is here called a local maximum point. So all we know, or all I want you to know, is that turning points, so a turning point or in another word, a stationary point or a critical point. These are all the same name for the same thing, okay? They're all the same name for the same thing, indicating only one thing, that the gradient at this point equals 0, and the tangent is a horizontal line at this point, okay? Two furthermore things that we could name it is a maximum point or a minimum point. This is another name which is more specific. It decides also the nature of the turning point. Is it like this or is it like this? Okay, so let's see how we can find those turning points and how can we classify them to maximum or minimum, because they're important in the sense that they help us to draw the graph, to sketch the graph, and they help in other applications as well. So let's start by recalling something from previous videos, which I'm going to leave its link on the top right corner. You can click and watch it, feel free, it's super helpful. We know that if we have a function which is f of x, the derivative of this function or the differentiation of this function, f dash of x, is basically the gradient function, or it's a function that shows me what happens or what is the gradient at a specific point x. Okay, so if we have, let's say, a function y equals negative x squared plus 4x plus 5. If I want to get the derivative, and I've also done a video on how to get differentiation for lots of different functions, even special functions, you can watch it. The differentiation is going to be negative 2x. I'm using the power rule, 2 times coefficient, 2 times negative 1 is negative 2, x, and then reduce the power by 1, plus 4. This is going to be the first derivative or the differentiation of this function, which indicates the gradient at a specific x, meaning that if I want to find the gradient at any x, I just can substitute this x over here, and then it will give me a value which is going to be equal to the gradient. So for example, if I want to know what is the gradient at x equals 1, I will substitute x with 1. So negative 2 plus 4, that is going to give me a value of 2. So at x equals 1, the value of the slope is positive 2. So returning to this turning point, all I know is that my turning point, the gradient is going to equal 0. So in other words, I want to know what value of x will I put in my first derivative that will give me an outcome of 0, because the outcome of this is basically the gradient. So I can work the other way around. So I can equate my first derivative to 0 and find the x. So this basically finds for me the x value where the answer is going to be the 0, or the gradient is going to be 0. So to find x, I can move the 4 to the other side. It's going to be negative 2x equals negative 4, divide negative 2, divide negative 2, x equals 2. So this tells me that the point where x equals 2, this is the x coordinate of the turning point. All I know about now is that at x equals 2, it's a turning point, it's a critical point, or it's a stationary point. I don't know if it's a maximum or a minimum. All I know is that the gradient is going to be 0. It could be this, and it could be that. Right. Let's see if this is correct. Okay, so I've prepared this function over here, which we solved. Okay, and if we want to find this point over here, if we look, we will find that the coordinates is actually an x of 2, and we can see that this point over here is a local maximum, meaning that it's a critical point. So our answer is correct. If you want to find the y coordinate, it's super easy. You just substitute this x into the original function. So it's going to be negative 2 squared plus 4 times 2 plus 5. So it's going to be negative 4 plus 8 plus 5. This is going to give me an answer of 9. So my stationary point is at a point of coordinates 2 and 9. So this is basically how to find the coordinates of a turning point. Let's take another example. let's say we have y equals 2 equals x squared minus 10x minus 3. So we want to find the coordinates of the turning points. That's the question. So the first step is that we need to get the first derivative, which basically means that differentiating this function. So it's going to be 2x minus 10. And then we equate the first derivative to 0. And then we find the x that will make this 0. So 2x equals 10. Just move this 10 to the other side, becomes positive 10. Divide by 2, divide by 2, x equals 5. So this tells me that my turning point happens at an x equals 5. If I want to get the y coordinate, I'm just going to substitute this over here. It's going to be 5 squared minus 10 times 5 minus 3. So 25 minus 50 minus 3. So this is a negative 25 minus 3. So the answer is negative 28. So my turning point is at a coordinate of 5 and negative 28. Let's test if this is correct. So this right here is the second curve, or the curve we solved right now. And as I can see that my turning point, or the critical point, is at a coordinate value of 5 and negative 28. Okay, so up until now, we know how to find the turning points. Let's see another example that could illustrate to me how to classify those turning points, how to see if it's a local maximum, if it's a local minimum. Let's see how to do that. So let's say we have a function y equals 2x cubed minus 3x squared minus 6. So again, we need to find the coordinates of the turning point first. So let's say we want to get the first derivative. 3 times 2 is 6. x3 minus 2 is 2. Minus 2 times negative 3 is negative 6. And then x power 2 minus 1, or power 1. And we know that differentiation of a constant is 0. So this is my first derivative. So as always, I will equate my first derivative to 0 in order to find the x coordinate of the turning point. So I can take a 6x out of this quadratic function over here and try to solve. 6x squared divides 6x is basically x, and then minus 6x divides 6x is basically minus 1 equals 0. So I know that to solve this, I need either 6x to equal 0 or x minus 1 to equal 0. And by the way, I have a whole series of quadratics and how to solve them on the channel, which I'm going to leave the link also on the right hand corner. So solving this, my first x is going to be 0 and my second x is going to be 1. So basically, this tells me that I no longer have only one critical point. I have two critical points, and these are the x values at those critical points. Let's test if this is correct. But before that, let's try to actually classify each turning point to know is it a minimum or a maximum. How to do this? This is done using something called the second derivative test, or basically is requiring us to get the second derivative of this function. Second derivative basically means differentiating this function twice. So now we differentiated one time. Now we will get this first derivative and differentiate it another time to get the second derivative, which is written as y double dash or d squared y by dx squared. They're both the same notation for the second derivative. So let's differentiate this expression. Is going to be 12x minus 6. So this right here is my second derivative, or it's going to be the thing that I'm going to use to test my turning points. Are they a local maximum or are they a local minimum? So how to do that? The test goes like this. We substitute our x value of the turning point we found. So if we're interested in the first turning point where x was 0, minus 6. And we see how much does it give us. 12 times 0 is 0, minus 6 is a negative 6. So we don't really think about the value as much. We only are interested in the sign of the answer. If the answer is a negative answer, then my turning point that I tested is a local maximum point. And if the let's test the second point. So 12 times 1 minus 6, this is going to be 12 minus 6, which is 6. If my answer is positive, regardless of what's the number, if it's positive 6, if it's positive 600, it doesn't matter. If it's a positive, then it's a local minimum stationary point. So let's see that. So we know that at x equals 0, this should be a maximum, and at x equals 1, this should give me a minimum. Let's try and test that in the same curve we were solving over here. So this curve looks something like this. So first of all, we had at x equals 0, we had a turning point, and this is true. And we classified the point where x was equal to 0 as a maximum, and we can see from the graph it is actually a maximum over here. And the second turning point was at x equals 1, and this is shown over here, and we classified it as a minimum, and as seen from the graph, it is actually a minimum point. So this is how to use the second derivative test in order to see if your turning point is a maximum or a minimum value. Type. Very quickly, we can take another example, okay, which is y equals 1 over x minus 4x squared. We need to find the coordinates of the turning points, and we need to classify them. So the first step is always finding the first derivative, which is going to be, okay, I can rewrite this expression as x power negative 1 minus 4x squared to be easily differentiated. So now trying to differentiate this is going to be negative x power negative 2 minus 8x. Or I can rewrite it as negative 1 over x squared minus 8x. And then, as always, to find the coordinates of the turning point, we equate our first derivative to 0 and solve for x. So plus 8x plus 8x to both sides. I'm going to have a negative 1 over x squared equals 8x. Multiplying x squared both sides is going to give me a minus 1 on this side and an 8x cubed on that side. Then I will have a negative 1 over 8 equals x cubed. So x is going to equal cube root of negative 1 over 8. This is going to give me an x value of negative 1 over 2. So this is basically my x coordinate of the turning point. Let's right away try to classify this turning point, if it's a maximum or if it's a minimum. So to do that, we need the second derivative, which is basically differentiating the first derivative. So y double dash is differentiation of this expression over here. It's going to be negative 2 times negative 1 is basically 2x, and then negative 2 minus 1 is negative 3, and then differentiation of negative 8x is minus 8. So this is the expression for the second derivative. We can rewrite it as 2 over x cubed minus 8. Let's try and test our point over here. So we will substitute the x coordinate of the turning point, which is negative half, onto the second derivative. So it's going to be 2 over negative half all cubed minus 8. This equals to 2 over negative 1 over 8, distributing the power, minus 8. So I know that 2 divide negative 1 over 8 could be written as 2 divide 1 negative 1 over 8 minus 8. This is the same as 2 multiplying the reciprocal of this, so multiplying negative 8 minus 8. So it's going to give me an answer of negative 16 minus 8, which is negative 24. So again, from our test, we know if the second derivative is a negative answer, then it's a local maximum. And if the second derivative is a positive answer, then my stationary point is a local minimum. So since the answer here is a negative, then I would expect this to be a local maximum. And let's test this over here. We can find that at x equals negative 0.2, we can have our turning point, and from the graph, it's seen that this turning point is actually a local maximum. Hope this video was helpful. Please don't forget to like, subscribe, and if you have any questions or any suggestions, any topics, any difficulties, you can freely ask them down in the comments below. I'm gonna read all of them. Again, don't forget to subscribe. Thank you so much for watching and have a nice day.